Welcome to Finding Stuff Out. If you're wondering why I'm in the dark, I'm conducting a scientific test inspired by an interesting question I received.
Do carrots really help you see in the dark?
Of course they do. Have you ever seen a rabbit wearing glasses? Nah. Seriously though, I don't know. But by the end of the show, I will eat all of these carrots, then I'll be able to see in the dark and answer this other question.
How come so many people are afraid of the dark?
Sometimes I have to admit, I'm a little scared of the dark myself. What about you?
Ask a friend.
When I'm in the dark, I think there are zombies, ghosts, creepy things.
There might be monsters. You feel very uncomfortable.
There might be ghosts that could invade your body.
Sometimes I just feel like someone's watching me in the dark. You think the scary movies are gonna come true?
There's nothing that scares me. Boom. First, guys, I suggest we get to know our enemy a little better.
What is darkness?
Well, Abdul, I checked, and darkness is an absence of light, like this. See, I'm in total darkness because there's no light.
Light is a form of energy that we can see. When light bounces off of things, that's how we can see them. So darkness is just when there's no light.
Here's a question from Amber.
Why is it daytime here and nighttime somewhere else?
Earth, the planet we live on, is lit up by the sun. The Earth is constantly spinning, so when one part of the Earth is lit up by the sun, that's what we call daytime. And the part that's facing away from the sun is what we call nighttime. So remember, the Earth is constantly spinning. So wherever you are and it's daytime, 12 hours later, it will be nighttime for you.
What is a solar eclipse?
Flat Earth Corner!
What is a solar eclipse? It's when the sun disappears from the sky during the daytime and the world is plunged into terrifying darkness.
And if you're a Viking warrior like me, living more than 1,000 years ago, you know exactly what causes eclipses. Eclipses are caused by a warg. That's a kind of wolf with superpowers, eating the sun. They're huge! And apparently, they like very, very hot food. Oh boy, that warg wolf is out again, eating the sun. I hope it won't be dark forever now.
That's a relief. The sun is back.
I guess that giant wolf didn't really like the taste of that sun so much.
Eclipses aren't really caused by giant wolves. They're caused by the moon.
I found out that the moon circles Earth all the time, and once in a while, the moon comes between the Earth and the sun.
Hello? Trying to have some daytime here. You're blocking my light. Oh.
I'm going as fast as I can. When it does, it blocks the sun's light for a few minutes, causing an eclipse.
Ah, that's better.
Does darkness affect plants to grow?
That's a good question, Sasha. But I don't think this carrot will give me an answer. It's not very talkative. And I checked. All plants need light to live and grow. Some can survive with just a little, but none of them can grow in the dark. Mushrooms can, but they're not a plant. They're something called fungi. They don't need light like plants do, and they get their food from rotting stuff. Of course, plants aren't the only thing that are affected by darkness. Animals are affected by darkness too. Here's another question from Alessandra.
Are owls and bats afraid of the light? I think I know someone who can answer that. She knows about owls who fly around at night. They don't crash into stuff because they have amazing sight. Here, Jennifer's here to buy. I see you brought a friend.
I have. This is Dweep, our grandpapa great horned owl. He's actually 30 years old.
Wow, I'm glad I know your name. So now I don't have to wonder who you are. What kind of owl is Dweep?
This is actually a great horned owl. as you can see by these awesome horns he has on his head. They're not really horns, they're actually just tufts of feathers that stick out from his head, but from far they kind of look like horns.
So, to answer your question, Alessandra, Jennifer says that we don't know if they're afraid, but bats really don't like light. Oh! She says owls like Sweep don't mind daylight. But when darkness comes, these great night hunters, woohoo, rule the sky.
How is it possible for owls to hunt at night?
Oh, well, owls are really special. They have these special eyes that help them to see better in low light condition. Now, if you look at his eyes, you'll see compared to his head, his eyes are huge. If we made his skull as big as a human skull, for example, we'd have to have eyes the size of grapefruit. I'd look quite pretty with eyes the size of grapefruits, right? Now, being that those eyes are so big, those pupils, the little black circles that you see in the middle of their eyes, those are also can become really big. The bigger the pupils, the more light comes into their eye. And that means they can see better. Now, their eyes are so big, though, that they can't really move them. So you see what I'm doing with my eyes? These guys can't do that. Their eyes stay fixed.
Yeah.
So because they can't move them, they've adapted other ways of being able to see all around them. So I'm gonna ask you to help me demonstrate. I'm gonna ask you to stay straight. Don't move your body at all. Just turn your head as far as you can turn it. So how far are you going?
A little past my shoulder.
So we'll say it's about 90 degrees from the front axis all the way to the shoulder, right? An owl can do 3 times as much.
Wow.
So they can turn to the shoulder, to the back, and even to the next shoulder without moving their bodies. Cool. And they can do that on each side. Pretty neat.
Cool. What else helps owls fly in the night?
Good question. Well, actually, they're really, really stealthy. They actually have what's called silent flight, or I should say silent flight. Because what happens is when they flap their wings, you don't hear anything. So I'm gonna demonstrate for you.
Okay.
I have 2 feathers here. I have a small one, that's for the owl, and I have this larger one, that's an eagle feather. Did you hear that one? Now for the owl feather. So you can see there's quite a difference, right?
Yeah.
Why would it need to be so quiet, an owl? What would it need that for?
So the prey couldn't hear them and he could catch them.
Bingo, exactly. To be able to surprise that little mouse. It's also in order to be able to
Listen.
hear the little mouse. That was a little yawn.
What else helps owls catch their dinner in the dark?
Oh, well, to show you that, I'm gonna bring out a different owl.
Okay.
So let me introduce you to Novio.
That's so cool. He moves his head around. It's like he's dancing. Why does he do that?
Actually, this is a barn owl. And barn owls, if you look at the faces, their face is shaped in the shape of a heart or a circle, if you will.
Yeah.
And that's what's called a facial disc on an owl. All owls have them. Now, barn owls, their facial disc helps bring the sound to their ears, which are hidden beneath the feathers on each side of their head. So with that facial disc, he's able to hear things more clearly, so he can hear all sorts of sounds. And the reason why he's dancing is he's kind of trying to make that facial disc a little bit bigger. Well, the more he moves his head, the more he's able to hear sounds. These guys have such amazing hearing that they can hear little mice 30 centimeters under the snow.
Wow. That's so cool. Thanks, Jennifer, for being on my show.
Thank you for having us.
Well, owls finding their way in the dark gives me an idea for...
My great challenge!
I'm the addict with my 2 challenges. Ruby?
Hi.
You're going to be Team Dweep. Sasha?
Hey.
You're going to be Team Novio. You're gonna have to use sound to hunt like an owl, but I'm not going to turn the lights off because that wouldn't be very interesting for the people who are watching, will it?
No.
So you guys are going to be blindfolded, and you can only use your sense of hearing to catch your prey, like this one. So are you guys ready?
Yeah.
Then put your blindfolds on and start hunting in the dark. Oh, Novio got the first one. Let me put it in your basket. second one. Okay, let me put it in your basket.
The next one is a little sneaky.
Here, got it.
I got it.
Okay, you guys both get a point. It's a tie. Got it. Nice job. Okay, this is the last one now. You guys ready?
Yeah.
Novio got it.
Shweep, you have 3. And Novio, you also have 3.
Which means you guys both win.
Yeah!
Was it weird hunting for your dinner in the dark?
Yeah,
Why?
because I like eating my food.
And was it difficult for you, Shweep?
Yeah.
Why?
Because it was hard walking, you could probably trip.
Yeah.
Uh-oh, do try this at home. Emerald and Linnea have an experiment to get an idea of how an owl's hearing works. Let's pretend a little mouse is scurrying around the house. Just listen. Next, cup your ears with your hands.
Do you hear better? I hear better.
Now, make a simple cone.
When did you hear the mouse better? Well, with my ears, I heard it a little. With my hands, I heard it a little bit more. And with the cone, I heard it very well.
I found out from Jennifer that the barn owl's face works sort of like cones, funneling sound to its ears. Now, here's David and Adeline with another owl experiment. Owls' eyes are amazing in the dark. One reason ours aren't as good is because our pupils are smaller compared to the size of our face. With the lights on, your pupils are about this size. But turn off the lights, and your pupils get bigger to let more light in to help you see. After staring at a bright light, let's see how long it takes Adeline's eyes to adjust to darkness and see what's on the black cloth. Go!
I can't see it at all.
Look. See? Do you see anything?
No, not yet.
If Adeline had owl eyes, she'd see in the dark much better and much faster.
That's so easy.
Maybe it's something with wings. I think it's a bat.
Well, you were right.
Boom! Bats are night animals, so they've developed ways to fly and hunt in the dark.
But how do they do it?
Here's Batgirl Corey Lawson. Hi, Corey.
Hi, Zoey.
So, can we start looking for bats?
That sounds like a great idea.
All right, let's go.
Okay.
How did you get the name Batgirl?
Well, when I was young, about your age actually, we had a bat in our house. And it was clear that my parents were really scared of it. And I thought, how can adults be scared of something so tiny? So then I went to university. I ended up learning a lot about bats. And, well, I've been studying them ever since. They're fascinating.
Cool.
Yeah.
So, what's gonna happen tonight?
Oh, well, the bats are sleeping now during the day. They're hiding under the bark of the trees, and some of them are in buildings. And then as it gets dark, they're going to peek their head out, look around, make sure the coast is clear, and then they're gonna dart out and go look for some food and water.
Wow. To answer the question, are bats afraid of light?
Well, I don't know if they're afraid of the light, but we do know that if they go out during the day and try to fly around, the crows or hawks or other predators will try to eat them. So it's a good thing that they do just fly at night.
Besides the things that want to eat them, are there any other reasons that bats come out at night and not in the light?
Yeah, there are a lot of insects that come out at night, like mosquitoes and moths, right? And so there's a lot of food for bats, so it's a good time for a bat to be eating is at night. If they tried to eat the insects during the day, they would be competing with other wildlife, like birds, for example, swallows. So at night, they've got the skies to themselves.
Once nighttime sets in, bats get busy. This lake is a great spot for Corey to use her special equipment.
These are bat detectors. And so what they do is they turn the ultrasound that bats are producing into something that we can hear, and they show you on the screen what the bat calls look like.
Cool. But what exactly is ultrasound?
It's sound that's too high in pitch for us to hear. So the bat detectors will lower the sound so that we can actually hear it. Now that's called echolocation. When bats go out and produce ultrasound, they will listen for the echoes of the sound to come back. And that way they won't run into trees and they'll find the bugs to eat them.
Cool.
So we just point the detectors out over the water, and the bats are going to come in and they're going to get a drink, just like that. See, that's a bat, and we can see the ultrasound calls that it's producing. That's its echolocation. It can find the water and some bugs to eat.
That's awesome.
Oh, look, it's Felix, my research colleague. And he has a bat that needs to be released. When he releases it, we'll be able to record its ultrasound.
Cool. Hey, Bat, I see your ultrasound. Have a nice meal.
Well, thanks for being on my show and helping me find out about why bats love the dark.
You're welcome.
Now, here's a question from Alexa. Are there any animals who live in total darkness?
Total darkness? Like complete absence of light? Head getting warm? How could an animal function in total darkness? How would it know left from right and day from night? Synapse is getting out of control! Reaching overload!
You're gonna make my head explode!
Oh,
Yeah, I'm definitely not a creature who could live in the dark. But amazingly, they do exist.
Creatures like worms burrow in the ground and have no eyes. Moles do have eyes, but they're super small and can only detect dark, light, and movement. Moles spend all of their life underground. An insect called a springtail has no eyes. It lives in caves nearly 2,000 meters deep. That's like about 4 CN towers. And these cavefish live in total darkness and have no eyes at all.
well, I found out a lot of stuff about the dark. And now it's time to answer the question that inspired my dark quest.
Do carrots really help you see in the dark?
Well, Maxime, the big answer is... they don't! I checked and I found out that although carrots are good for you, they don't actually help you see in the dark. It was just a rumor made up by the British government during World War II to explain why they were able to catch their enemies' airplanes at night.
They said that because they didn't want the enemy to know that they had made a huge invention, the airborne radar. It works sort of like the way bats find their prey, sending out signals that bounce back and tells a radar operator where the enemy plane is.
Hey, that's my idea! The carrots didn't help me see at night, so it didn't help me answer this question from Leonie. How come so many people are afraid of the dark? Well, Leonie, I checked and I wrote this song to explain it.
Fear of the dark is an instinct from a very long time ago, when hyenas and tigers prowled in the gloom and leopards and lions roamed. Our ancestors were afraid of the night, 'cause they couldn't see what was watching them and getting ready to bite. But now we live in houses, there are no lions here, so we can sleep in the dark, there's nothing to fear here. There are no lions here, there's no lions to fear here.
So our fear of the dark is an instinct from a very long time ago. But since then, people have invented lots of ways to live and work in the dark. Inventions like radar, electric lights, and night vision goggles make it possible for us to go about our day-to-day lives in ways that our primitive ancestors could never have imagined. So, just like our instincts tell us not to jump off a cliff or put our fingers through a flame, we still have instincts that tell us to be afraid of the dark. But I know it's just an instinct, so I'm not scared of going to sleep in the dark. Thanks for watching my show, and see you again next time for more Finding Stuff Out.
Something big in the dark. It's a predator. Maybe a tiger or a carrot? Hope I didn't scare you. This is a moose caller, and that moo was a moose call. I'm using it because today I'm going into the woods to explore a place that I've had a lot of questions about, including this one.
Do we need forests?
Well, Julia, I don't actually know. I mean, it seems like a nice place, but do we really need forests? What do you think?
I don't know.
By the end of the show, I'll have the answer. Meanwhile, here's a question from Alessandra.
Is it bad to cut down trees in the forest?
The Flat Earth Corner! Is it bad to cut down trees in the forest? Of course not. Look how many there are. If I cut down trees forever, there would still be a lot more. Where'd all the trees go? People used to think that forests were endless, and they could cut down as many trees as they wanted. And there were a lot of forests. I checked, and scientists think that at one time, forests covered this much of the world. But because of people cutting down trees, the forest now only covers this much of the world. I found out that without forests, wild animals have no place to live. Nowadays, they even go into neighborhoods where people live. Animals definitely need forests for their home. And Amanda had a question about that.
How many kinds of living things are in the forest?
Living things like birds, mammals, amphibians, reptiles, insects, microbes, big living things, tiny living things, things that eat plants, things that eat the things that eat plants. And there are plants too. Head getting warm. Brain trying to imagine all those creatures. Must be 100. No 1,000. No tens of thousands. Reaching overload! You're gonna make my head explode! They're still discovering new species all the time, and no one knows how many kinds of living things are in the forest, but they all need to eat.
And we're going to meet some of them right now. She knows about animals that live in the forest. She's bringing some in now, and I know that they won't bore us. Here's Jennifer Sierra.
Hi.
Hi. This doesn't eat people, does it?
No, absolutely not. Don't worry. This is actually an American kestrel, and her name is Sapphira.
Where does she live?
Well, this is a type of bird that lives in open fields and meadows, often close to forests. So forests are a little bit like a refrigerator whereby sometimes the mice and the insects all come out. And when she can spot them, oh, she's in seventh heaven. That's the way she can find all sorts of yummy food to eat.
So what do you guys feed her?
Well, at the Eco Museum Zoo, we feed her mice and we sometimes feed her little birds because that's sometimes what they'll be eating in the wild as well. Would you like me to go and get some more?
Sure.
Excellent.
Wow, what kind of snake is that?
This is what we call a black rat snake. Sometimes people refer to them as gray rat snakes. It loves to climb up into trees. I know it's hard to believe considering it doesn't have any arms or legs, but these guys can actually climb very easily.
Does it bite?
They can bite. Would you still like to touch?
Sure. Whoa, that's like scaly. That's funny.
Those are all scales. They have them all over their bodies.
Wow, this frog is huge.
It's actually what we call a bullfrog because this is a large type of frog, just like bulls are pretty large.
So why is it good for them to live in the forest?
In the forest where they live, as long as it's near water, they'll be able to find all sorts of insects and all sorts of little mice to eat, and that's what they love. They can eat fish that are found in the water, as well as a mammal that flies at night. Bat.
Seriously?
Oh yeah, and you want to know how they eat the bat?
How?
Well, they have to launch towards it with their bodies, their mouths open, their tongues sticking out like this. They catch the bat in their mouths with their teeth, it keeps them in place, and then they push it down with their hands, the muscles in their throat. They have to bring their eyes inside their heads and push the food right down their throat.
That's so cool.
This is what we call an opossum, and this is from the marsupial group, so it's the same group as koalas and kangaroos.
What does she eat?
She can eat a little bit of everything, actually. She's rather omnivorous, so she can eat fruit, she can eat seeds and nuts, she can even eat other types of animals, like insects, mice. So you can see, if, like the forest floor, she's trying to push all the leaves around, all the pieces of wood, and she's trying to find all sorts of fruits that might have fallen from trees and insects that are hidden under all these branches, just like she'd be doing in the forest.
Thanks for being on my show and helping me find stuff out.
Thanks for having us.
Here's another question from Joseph.
Are all forests the same?
To answer that question, I've come to meet an expert on Vancouver Island that has some of the most beautiful forests on Earth.
She knows about the trees and all the forest things she sees. Here's Julie Fortune! Yeah!
So I brought you this little fir seedling. And one day, this little seedling is going to be a huge part of this big forest.
How tall could it grow?
Douglas firs can grow up to 60 meters tall and have really wide trunks.
Wow.
So the kind of forest it would live in is a forest like around here. It's a temperate rainforest. The kinds of trees we would find here are especially the Douglas fir, but also things like this arbutus right behind us. The arbutus is a very interesting tree because it sheds its bark in the summer instead of shedding its leaves in the fall.
What other kind of forests are there?
There are tropical rainforests.
Like the jungle in the Amazon?
Yeah. There are temperate rainforests, which is like the one that we're in right now. There are boreal forests further north. And there is this really cool thing called cloud forests, which are forests that kind of sweat and then they create their own clouds.
That's really cool.
Yeah.
Why aren't all forests the same? Like, why isn't a forest like the jungle?
Not all forests are the same because trees need three things to grow. They need light or energy, they need water, and they need nutrients. Light, water, and nutrients aren't spread out the same around the globe. For example, in the desert, there isn't enough water to grow forests.
What about in the Arctic? Here's a question from Neil, who lives there, way up north.
I live in Igloo. Why aren't there forests here?
You won't find forests up north in the Arctic Circle because it's just too cold for trees to grow.
Speaking of trees and forests, who's in the mood for a little experiment?
The experiment!
Did you know you can tell how old a tree is by counting its rings? Not these kind.
Not those kind of rings either. These kind. I asked my friend Kashvi Noah to count some rings. In the spring, trees grow very quickly, slow down in the fall, and then stop in the winter. This creates a tree ring every year.
I think mine's about 23 years old.
I think mine's about 37.
Wow. But that's so small.
Yeah, and that one's big. I wonder why this one's older, but it's smaller.
Well, I found out it's because trees are just like people. They grow in all different sizes. It also depends on where the trees are growing. Rings tell you a lot about climate change, like if the tree had enough water or how hot or cold it was that year. A wide ring means a tree had what it needed to grow, but a skinny ring means it may have had a tough year. So because rings are not all the same, they're tricky to count.
I think this tree was born in 1932.
That's like when my great-grandmother was born.
Well, mine was born in 1894.
That's like when my great-great-great-great-grandmother was born. That seems pretty old, but I found out that some trees have thousands of rings. The oldest is not that big, but it's still 5,000 years old. That's 5,000 rings. Imagine counting that.
My tree is 120 years old.
Mine's 84 years old.
Bye, Zoe.
Bye.
Thanks, Kashvi and Noah. Now here's a question from Andrew!
What do we get from the forest?
Off the top of my head, I know that we get wood for houses like this. And we get paper from trees in the forest. Try living without toilet paper. Thank you for that one, forests. I checked, and there are lots of other things that we get from forests. And that's the subject for today's My Great Challenge!
Today's challengers are Aiden and Tristan.
Yeah!
Justin and Sterling.
Yeah!
So Aiden and Tristan, your team Oak. Justin and Sterling, your team Pine. You see those items on the table, right?
Yeah.
Yeah.
Your challenge is to pick up what you think is made from things from the forest. The team that guesses the most correctly and the least incorrectly wins. Let's pull branches, to decide who goes first. And Team Pine wins, so you guys go first. But wait till I blow my super moose signal. 3, 2, 1.
Time to move.
I think we should pick the hockey stick.
Yeah, it's made out of wood. It's a good idea.
What about
Paper is made out of trees, right?
yeah.
So we should maybe take that.
Yeah.
We should take maple syrup. It's made in springtime from trees.
Should we take the birdhouse? It's made from wood.
What about this mask-looking thing?
Yeah, it looks like it's made of wood. What about this book? It's made from paper, so it's probably from trees.
Yeah. What about this toilet paper? The paper is made from trees.
Yeah. Now can we try the electric guitar?
Yeah, maybe.
The rocks are natural.
I think that's cool.
It's still natural. Let's take
Oh, yeah,
it.
it's true. We should take that. I don't know what it is.
I don't know what it is. Is it butter? We should probably take it.
Oh, paper. Yeah, paper. Maybe take that T-shirts.
Yeah.
Yeah, this box. Maybe this bouncy ball.
Maybe.
So just take ping pong balls. There's nothing else we can really pick.
Both teams are done. They did not pick the rubber boots, plastic container, or the rubber tire.
Are you sure everything on your table comes from the forest?
No.
I forgot to mention, you lose a point for every wrong answer.
I'll give you one chance to put everything back that you don't think comes from the forest.
Back the guitar.
Yeah.
Maybe you should put that
Butter. And what about this ball?
Yeah, sure. Yeah, these ping pong balls.
Plastic.
Yeah. And they're ping pong-ish.
Okay, Team Oak, you have 6 items that you thought came from the forest. Team Pine, you have 9 items that you thought came from the forest. So the good news is, everything that you put on your table came from the forest.
Yes.
But the bad news is, everything that you put down or didn't pick up also came from the forest.
It was probably easier to figure out stuff like paper, maple syrup, or the hockey stick. But I found out that ping pong balls and fabrics can be made from tiny fibers from plants and trees, just like paper. Margarine can be made from palm tree oil. Rubber balls and ties are made with the help of rubber trees. That plastic container is made from oil. And just like coal, it's a leftover of forests that grew hundreds of millions of years ago.
So what are you guys most surprised about?
The ping pong balls and the guitar. Yeah, the guitar.
Yep, it's made of wood, but it's painted and varnished.
Well, thanks for being on my show and doing the challenge.
You're welcome.
Now I'm going back to the forest to see what else comes from there. I have a few guests who know the forest really well. This is Natanis and her family. This is Shia. This is Sequitin. And this is Hallie, and that's Natanis.
They're members of the Nocturnal First Nations, and they live here in a forest on Vancouver Island.
Natanis, why is nature so important to your culture?
Forest was everything to us. Instead of going to a grocery store, we would get all our food from here. Everything that we use to stay alive, our shelter, our food, or even our clothing. And sometimes we don't even notice the smallest little things was used for everything. Say what you're sitting on, Zoe. This is called sphagamos. And sphagamos was picked, and then all the sticks were taken out and to make it really soft, and they were used as diapers.
Wow.
It was the very first disposable diaper, and it was actually good for the environment. Shia brought you a basket.
Wow, it's so beautiful, thank you. I can't believe it's made of the forest. I'm so excited. This is a salmon. Wow, that tastes delicious.
This is an indigenous blackberry. It's like a little vine that grows. And the young girls used to like taking it here, and you would make a little hair ornament, and the girls would wear it and decorate their hair. You'd spend all day out here, and you'd be singing songs, and you'd be singing to the trees, and you'll also be letting the bears know that I'm here.
We're out in the middle of the woods looking for plants and berries, so we have to sing a song to let the bears know that we're here. Bears hate surprises. If you surprise a bear, he might think you're threatening him, and he could attack to protect himself. Singing lets him know that you're coming and don't mean any harm. Bears like to be alone, and usually they'd much rather be out of your way.
All around us, right in this one little area, we have all different kinds of medicine and food. So everywhere you walked, there was something that we used. Cedar was the most used tool of the coastal people. Huge canoes would be made out of this, and they would be pounded into very fine fiber, and they would be made into clothes.
I never thought that you can use so much things in the forest. Thanks for being on my show.
You're welcome, Zoey.
I think we're getting closer to answering if we need forests. Animals for sure need forests. And we need a lot of stuff we get from forests. But are they good for anything else? I think I have time for a couple more questions.
How do forest fires start?
I checked, and I found something out super surprising. Fires are a natural part of the forest life cycle. Lightning causes lots of forest fires, but experts say that can actually help trees. Forest fires are as important to the forest as the sun and the rain. Some trees, like these giant sequoias, depend on fires to reproduce. Their cones need heat to open and release their seeds. Ashes make great tree food, and more sunshine gets through, helping new bushes and trees grow a lot better. This is good for animals looking for food, but some fires can be really bad. Hey, where did everybody go? It's bad for forests when fires get out of control. Most forest fires are caused by one living creature. Can you guess which one? Nope. It's this creature, humans! When you're finished toasting your marshmallow, make sure the campfire is out. Here's a question from Pierce.
Does the weather change because of forests?
I did a little research, and to answer that question, I've made an animation. Forests affect the weather and climate in a lot of ways. First, they draw a gas called carbon dioxide out of the atmosphere. Carbon dioxide is a greenhouse gas that heats up the atmosphere. So having forests help keep the Earth's temperature from getting super hot. And forests create shade, keeping things cool beneath their leaves. Their root systems absorb water, which helps prevent flooding.
Cool.
Without trees to soak up water, rivers could flood more easily and deserts could spread because the water runs away instead of being stored in the trees.
Aww.
Don't you breathe easier knowing that forests are taking care of us? Hey, that gives me an idea for... Uh-oh, do try this at home. Here's something super easy, but I bet a lot of you don't do this. Next time you're in the woods, take deep breaths of fresh air. I found out that some scientists say that just being in the woods can make us healthier and happier. What do you think?
Ask a friend. I really like being around trees.
Makes me feel like I could do anything I want because there's so much space.
I would like to play in it, but I would stay there forever.
You can hike and it makes you feel sporty.
I like a lot of things about the forest. There are a lot of relaxing noise in the forest, of like birds, water, It relaxes you. I like climbing trees. I feel happy, excited, and alive.
So if you're ever camping or in the park with lots of trees, try it out. Listen to the sounds of the birds and the wind in the leaves. Take a deep breath of freshly made oxygen and smell the soil in the plants.
It just might make you feel better and healthier. And that takes us back to the question that started it all. Do we need forests? Well, Julia, the big answer is... yes. And I wrote a song inspired by your question.
The forests are a swinging place for monkeys, moose, and bats. Bears, raccoons, wolves, and weasels, it's their habitat. Tigers, bugs, gorillas, snakes, orangutans, and bees. The world looks different when you see the forest for the trees. Wood for houses and for warmth, chairs and piano keys. Toilet paper, cardboard boxes, and tissue when we sneeze. Achoo! Medicine and furniture and oxygen to breathe. The world looks different when you see the forest for the trees.
That's my show for today. See you next time for more Finding Stuff Out. I think I'll hug a tree. Ow, you're prickly. Maybe I'd be better off hugging a moose. Moo! Moo! Welcome to Finding Stuff Out. Things have been a little alarming today. I found out the snack I was eating was poisonous. I'm eating poison? Fortunately, I remained calm. Okay, maybe not so calm, but turns out I was fine. Sort of a funny story. I read grapes are poisonous, but I didn't finish reading the sentence. Turns out they're poisonous to dogs, but they're totally healthy to us people. Wait, how can something I eat be poisonous to my dog? I mean, poison's poison, right? You know what else is poisonous to pets? Chocolate, raisins, avocado, gum, garlic, walnuts. Shouldn't we be able to eat the same foods? It's not like I would die if I ate a dog biscuit. Or would I? So confusing! Ah! You're gonna make my head explode! I'm determined to get to the bottom of this mystery. Maybe Maxim's question will help.
What exactly is poison?
The short answer is, I don't know. Poison seems more complicated than I realized. But by the end of the show, I'll have the answer. Meanwhile, here's another question. Why are some frogs poisonous? Well, Tegan, let's find out. He's an expert on animals that poison and bite, so I guarantee it'll be a delight. Please welcome Jesse DeLuca.
Hi, Zoe.
Hi. Wow, the frog is so colorful. It looks like it's made out of candy.
But you don't want him in your trick-or-treat bag. He's poisonous.
I've never seen a frog like this. What kind of frog is it?
This is a poison dart frog from South America. It gets its name because hunters used to use its poison on the tips of their darts. Poison dart frogs have some of the most brilliant and beautiful colors on Earth, but they are also the deadliest creatures on Earth. The golden dart frog, for instance, is known to be ounce for ounce the most toxic animal on the planet. Its poison is so powerful, only one drop can kill 10,000 mice. That's like 10 to 20 grown humans.
Yikes! So how dangerous is this guy?
Well, I was only kidding earlier. It's not poisonous at all. If it was in nature and eating the stinging insects that it usually eats, then it would be poisonous. For example, if he was eating little stinging ants, the stinging chemicals in their venom makes them poisonous.
So what do you feed him then?
I feed them little fruit flies and little tiny crickets.
Why are some types of frogs poisonous and others aren't?
Some frogs evolve to be poisonous and predators learn not to eat them.
That seems like a big advantage. Why don't other frogs have that?
Well, some frogs are poisonous, and then there's others that evolve to camouflage. I believe that frogs become poisonous due to the environment they live in and the food that is found there.
Cool. I have a question I think you can answer.
Why doesn't the poison in the scorpion kill the scorpion?
Well, Vulcan, you think I'm gonna have a live scorpion on my show? Well, you're right.
This is an emperor scorpion.
Is the poison in its claws or its tail?
It's actually in its tail, and it's not poison, it's venom.
What's the difference?
Poison is something that an animal has to help protect itself. If you eat it, you'll get sick.
So what's venom?
Venom is something that an animal has to kill its prey. The venom has to get into your blood. Just think of the frog and how its poison is for defense, and the scorpion has its venom for attack.
Defense versus offense. I think I feel a song coming on. Defense. You can't eat me. Offense. I'm so hungry. If you want a piece of this, I'm in the mood to pitch. If you want a piece of this, I will make you really sick. If you try to take a bite, then you might be dead tonight. With my venom, I'll attack. I will paralyze the snack. But I won't eat you today. You're not tasty anyway. Yay, team! Sorry about that. Sometimes I just feel a little musical.
No problem.
So how does the scorpion actually use its venom?
The scorpion uses its venom with its stinger. It stings its prey to paralyze it.
What would happen if it accidentally stung itself?
Some scorpions have anti-venom in their bloodstream that prevents them from getting hurt from stinging themselves. But if too much venom is released, it can end up killing itself.
Wait, if it stung me, would it kill me?
Scorpions can kill small animals. There's only a few scorpions that can actually kill humans.
Oh, phew.
But if you were to get stung, it would affect you. It would hurt.
That reminds me of another question I got.
Can you hold a tarantula without being bitten?
Well, Anjali, we're about to find out.
It's actually best not to hold a tarantula. This is a Brazilian black tarantula.
I'm gonna guess it has venom instead of poison.
That's right, it has venom. It uses its venom to inject its prey to paralyze it. This one actually doesn't spin any webs, it hunts down its prey.
Do all spiders have venom?
Because they don't have teeth, yes, all spiders do have venom. But their venom isn't very strong on humans. It's more like a wasp or a bee sting.
Yikes. Ask a friend. What would you do if you saw a tarantula or a scorpion?
Run for your life. I would faint. I would take a stick and get it off. I would scream and cry and run away. Take it off my leg and then squash it. I would have a heart attack. I would shout, "Ah, tarantula!"
How can we actually avoid being stung?
You just want to leave it alone. If you don't bother it, it won't bother you.
So if you held the tarantula, would it automatically use its venom on you?
It might, but it doesn't want to use up its venom. It doesn't have an unlimited amount.
Well, thanks for helping me find stuff out.
My pleasure.
So tarantulas have to be careful not to use all their venom. Hey, that gives me an idea for...
My Great Challenge! Welcome to the Great Tarantula Challenge! Hope you're hungry.
Today's challengers are...
Dario! And Alessandro!
I hope you're not scared of spiders. You're going to be tarantulas. You each have giant venom squirters. You have to knock over your prey by squirting water, venom at it.
But be careful, because you don't want to hit anything that tarantulas don't eat. Don't use too much venom, because when you run out of venom, you're done. Are you ready?
Yeah!
Okay, Dario, you'll go first. On your mark, get set, attack! Dario's going for an all-out attack. Ladybug. Yep, tarantulas eat mostly insects. Pretty much any insect they can catch. Even flies, mosquitoes, or bees. They are all delicious. More venom pressure. Not easy to catch your lunch now, is it? Uh-oh. Dario is lucky he didn't knock down that robot. Tarantulas do not eat robots. Looks like you're running out of venom, Dario. Dario got 10 snacks. Let's see if Alessandra can beat him. Almost got it. Nice, you caught a butterfly. A mouse. That's good for 1 point. Some species of tarantulas will actually eat mice, frogs, or even birds. Nope, you lose a point. Tarantulas do not eat flowers. Hey, I'm not a bug. Okay, Alessandra, it looks like you ran out of venom. Let's see who won. So, Alessandra, you knocked 8 prey down.
Yes.
And Dario, you knocked 10 prey down, so you win!
Yes!
Thanks for playing. Oh, and because the challenge probably made you hungry, here's a snack. Of bugs!
Well, that's an easy prey.
And here's another question from Emanuela that you can sink your teeth into.
How come some snakes are poisonous and others are not?
Ha! You can't fool me. Snakes can be venomous, but they're not poisonous. If they were poisonous, you'd get sick from eating them. And some people eat rattlesnake. I checked whether snakes have venom or not. Depends on how they catch their food. Some snakes don't need venom at all because they catch their prey by squeezing it until it suffocates. Imagine if you had to squeeze your lunch like that. But other snakes use venomous bites to paralyze their prey and sometimes to pre-digest it. I wonder what that looks like. Kiana and Maxim have an experiment to find out.
The experiment!
This experiment shows sort of what snake venom can do to your blood. First, you add some red food coloring to milk.
That looks like blood, except it's like lighter.
Yep.
Then you add vinegar and see what happens.
Oh my gosh. That looks very, very, very weird. It's all separated like into little bubbles in its own section.
It looks like a sponge.
Yeah, it does.
The vinegar clots the milk, so it's all globby and yucky. That's sort of what snake venom does to the blood of its prey.
That's disgusting. I wish I never had to see that.
That looked disgusting. Are you sure you want to eat that? Okay. Thanks, Kiana and Maxim.
Bye, Zoey.
Ugh. Why can't we ever have pizza?
Fortunately for us humans, scientists have found ways to make medicine called anti-venom. I found out they milk snakes for their venom to make anti-venom. They can save you from a snake bite if you get the medicine in time.
Snakes a lot.
How can we eat poisoned food?
Why would I want to? Well, turns out some people do want to. I found out that the pufferfish is poisonous to keep bigger animals from eating it. You know, in case the spikes aren't enough reason to find a different lunch. But chefs in Japan have a special way of preparing pufferfish
That gets the poison out. There's just a teeny little bit left to make your mouth feel stingy. But if the chef makes a mistake, it can kill you.
To me, that doesn't seem worth the risk. But all around the world, people have discovered ways to eat poisonous foods safely.
I found out that in South America, they make flour from a plant called manioc, or cassava, which is super poisonous. To make it safe, first you have to scrape it, soak it, boil it, grind it into flour, and then cook it. That's a lot of work. Cassava is one of the most popular starchy foods in places near the equator, but it's poisonous if it's not prepared right. Even foods we find in the grocery store can be poisonous, like the leaves of rhubarb and potatoes.
And speaking of foods we need to be careful about,
How do we know if a mushroom is poisonous?
Flat Earth Corner!
There are lots of old wives' tales about when mushrooms are safe to eat.
I should know. I'm an old wife. I've heard that if they grow in wood, it's safe. As long as it's not red, it's fine.
I heard if you rub the red off, it's safe to eat. You know what? Maybe I should check first.
people used to have all sorts of rules about how to tell if a mushroom was poisonous. But those rules were only right some of the time, and if you weren't right,
I should have checked.
To find out more about poisonous mushrooms, I'm on the hunt for them with mushroom expert Mary Burby and some of her students, Vivian and Anna. What kind of poisonous mushrooms can we find?
Well, I can show you some of the pictures of poisonous mushrooms that have made people sick in this area.
Sure.
So this is the death cap here, and this is the destroying angel.
Death cap, destroying angel? I can tell by those names that they're trouble.
You are so right. The reason why they have those names is because if you eat a relatively small amount, like 2 mushrooms, then the poisons in the mushroom can completely destroy your liver. And fairly frequently they die. So if there's any group of mushrooms that you should learn to recognize by sight, it's the death caps and destroying angels. So you can always avoid those very carefully.
Yeah.
Oh, we're going on a treasure hunt for poison. Here, mushroom, mushroom, mushroom.
There's one.
Oh, good job.
That's really cool.
Isn't it though?
I found one. What's this?
Whoa, nice find. That's a mushroom called the prince.
Poison or lunch?
It is, in fact, lunch.
Horror, I'll put you in me treasure chest.
If I were to collect mushrooms in the wood by myself, how would I tell if the mushroom's okay?
There are probably 30,000 different kinds of mushrooms, and some are poisonous and some aren't, and the only way to know which is which is to get to know the individual kinds very well. One way that people often learn to do that is by going out with groups of experts. So they go out with mushroom clubs who have a lot of experience picking and identifying mushrooms.
If I were to eat a poisonous mushroom, what would happen?
Well, I hope you never do, because it's not a pleasant experience. What your parents would probably do is to take you to the hospital and they'd pump your stomach, which is not pleasant, but that would get rid of the poisons. The mushrooms that cause the most serious problem are the ones where you can't tell that you've eaten something bad for a long time, so it takes hours before you start to get sick, and by that time, there's not anything that they can do by way of pumping your stomach because the poison is all throughout your body.
And that's the problem with the death caps and the destroying angels. So I really hope you never get anywhere near those kinds of fungi.
Okay, I'm convinced. I'm glad you're here to help.
Anytime.
We found a lot of mushrooms, but no death cap or destroying angels, and I want to see real ones. So Mary brings me to the Beatty Biodiversity Museum to see their huge mushroom collection.
Shiver me timbers! Look at all these treasures!
That's the right attitude. They are indeed treasures, and they're preserved here so that scientists all over the world can study them.
Why are they all dry?
The reason why they're dry is because a fresh mushroom only lasts about 2 or 3 days, and then it becomes just a mass of slime. So the only way to keep specimens so that scientists can study them in the future is to dry them down. There's some that actually go back older than your grandparents are. Some mushrooms have distinctive smells. You want to smell a death cap?
Sure.
Anna and Vivian said that the death cap, when it's dried, has a particularly disgusting smell. What do you think? Is that disgusting?
I think so.
Take a look at this one here, because this is the one that's deadly poisonous. And one of the characteristics of the death cap is that it's got this cup. So the stem of the mushroom actually comes from inside of a sort of a cup. And if you see a mushroom that has a cup like that, don't eat it, okay? Because most poisonous mushrooms of all have that characteristic.
Thanks for helping me find stuff out. Arr.
No problem, matey. Don't forget your treasure.
I'm gonna eat you.
If the frog is red, you'll end up dead.
Maybe I'll eat your granola bar instead.
Good idea. No one wants to eat something poisonous.
Hey, I think that's the answer to today's big question.
What exactly is poison?
The big answer is...
Poison and venom are substances that help animals survive.
The dart frog's poison keeps animals from eating it. So does the pufferfish's poison, though chefs have learned to outsmart it. I found out that even plants use poison to protect themselves, like foxglove, which is extremely poisonous if you swallow it.
And if you think about it, even animals that use venom to attack are using it for survival.
Their venom helps them kill their prey, and they use the threat of venom to scare us away.
I'm definitely gonna stay away from poison, except for these green grapes. After all, I'm not a dog. See you next time for more Finding Stuff Out.
Hi there, I'm Mr. Bones, and I'm here, or maybe I should get out of here because of this question from Alessia.
I wonder what we would look like without bones.
No bones? Who would ever want that?
I actually think it would be kind of fun.
Well, that cuts me right to the bone.
Oh, I didn't mean it. I'm sure you're useful for something. I feel it in my bones.
Good one, yeah.
Well, Alessia, I'll find out what we'd look like without bones by the end of the show.
I've got no bones about it. Anyways, here's a question from Annalisa.
Does every animal have bones? I checked, and I found out that fish, birds, amphibians like frogs, reptiles like lizards, and mammals like us have bones inside our bodies. But it turns out the world has way more animals that don't have bones. So, which kinds of animals don't have bones? You've got your insects like caterpillars, butterflies, ladybugs, bumblebees, beetles, grasshoppers, and other creepy crawly things like spiders and centipedes. There's worms! They have no bones! Neither do lobsters or crabs! Jellyfish, squids, octopus, snails! There's so many! In fact, 96% of animal species don't have bones! That's almost all the animals on Earth! Ah! You're gonna make my head explode!
Oh, that's a lot of boneless animals.
But this great question from Belize really got me thinking.
Why are some boneless animals squishable and some not?
That's true. Not all boneless animals are floppy and squishy. Why do some have hard parts and others don't? Like these spiky sea urchins. They're so weird. To answer your question, I'm off to my local aquarium.
Have you ever held a sea urchin before?
No, I haven't, but can I try?
Yeah, let's try it out. So you want to hold out your hand? Here we go. Can you feel it moving on your hand?
Yeah. It feels so funny. I'm here with Celine, and she's helping me find out more about animals with no bones. So none of these animals have bones?
Well, except for the fishes, none of the animals in this room have bones. They're all part of a group that we call invertebrates. They don't have any backbones.
You'd think if you had no bones, you'd be all squishy.
Most of them would be squishy. They're called soft-bodied invertebrates.
Can I touch some of them?
Yeah. Why don't we try actually one of the most squishy of them? Do you know what kind of animal this is?
It looks like a sea cucumber.
That's right. This is a California sea cucumber. And you can see it actually starting to look like it's just gooing away.
Yeah.
That's because most of its body is water, so when it's out of the water, it can't retain it, and that's why it's so squishy.
This feels like slime. It's so weird.
This is called a box crab.
This crab doesn't look squishy at all.
That's right, it's not.
It's really hard.
It is really hard. A lot of invertebrates still have a hard outer shell, like this one. It's called an exoskeleton.
Oh, I see. So the exoskeleton's on the outside?
Yeah, it is. It's kind of like having an armor. It actually needs to do something that's called molting every now and then in order to grow. One of my crabs actually molted this afternoon.
Yeah.
And you can actually see
Whoa.
the way it looks like on the inside.
It's empty. It's like a hollow suit of armor. Why would a crab get rid of its shell?
Well, see, the shell is hard, so it doesn't expand. So when the crab needs to grow, it's gonna leave its old shell behind so it can make a new one. And it's soft for a little while, and then over a few days or a few weeks, depending on the species, it's gonna get hard again. It's gonna have a nice new hard shell to protect it.
Are there any animals that have shells?
Yeah, lots of other animals have shells, like oysters and clams, and even weird-looking animals called chitons, like this little guy.
It's like bumpy.
It is. That's all of its hard shell plates. And when it's scared, it's actually going to start going into a bowl to protect its soft body that's on the inside.
Wow. What about the squishy boneless animals? Why don't they have any armor?
Ah, that's a very good question. Tell you what, why don't we go meet our star soft-bodied invertebrates and find out?
Okay,
Yeah?
sure.
He's a little shy, but let's go see if we can find him.
Okay.
Ready?
Yep.
The aquarium squishy star is actually an octopus. And Selena's right. Octopuses are really shy.
Where is he?
It's a very good question. It's actually really hard to find.
Why?
Because they are really good at hiding. They can camouflage, but most importantly, they can fit in really tiny spots. They can squish their bodies in the smallest spaces. So there's lots of areas in this habitat where it could be hiding right now.
I wanted to ask you about a video I saw of an octopus.
The guy that made it drilled a really small hole through a plastic box. Then he put an octopus inside. The hole was really small compared to the octopus, but it squeezed through. It was amazing. It took a while, but he made it. I don't think that octopus could have squeezed through if he had a shell.
Yeah, if you had an exoskeleton like the crab that we saw before, do you think you could fit in a very small space?
Definitely not.
No, but octopuses, some of them can weigh up to 300 pounds, but they can still fit in a hole as small as an orange. They're really good at escaping. If there's a space where they can fit in to go somewhere, they will go there.
Yeah. Thanks, Celine.
Now here's a question from Jeremy.
How do octopi move?
Well, Jeremy, I checked, and they actually have some very special muscles in their body that work without needing bones. It's sort of like how your tongue moves without bones. They also have suckers on their arms that let them push themselves along the ocean floor. So it would be like if my body were made of tongues and suckers on them. That would be weird.
Does a jellyfish feel squishy? Because it really looks squishy.
Well, Jenna, the aquarium also has lots of jellyfish.
I'm here with senior biologist and jellyfish expert, Mackenzie. Do jellyfish feel squishy?
Well, why don't you try touching one and tell me what you think? What does it feel like?
It feels like jelly.
It does, doesn't it?
Are jellyfish made out of jelly?
No, believe it or not, they're mostly made of water.
I always thought jellyfish were made out of jelly. I always thought jellyfish could sting you.
They can sting. All jellyfish sting, but some have a stronger sting than others. These ones have a very, very mild sting, so you won't even feel it. And the stingers are located all around the outside of the bill there.
Do jellyfish have eyes?
They do have eyes. They have eyes around the edge of the bell, and that helps them sense where they are in the ocean and in the water column, so they're always swimming up.
So cool. Thanks for helping me find stuff out about squishy animals.
Go, go, go! Jellyfish, squids, octopuses, and other creatures like cuttlefish and nautilus use a kind of water jet propulsion to zoom away. Cuttlefish, octopus, and squids can also shoot out ink that spreads in the water to confuse predators. How do they do that? To find out,
Do try this at home.
in this experiment, Daniele and Andrea will use these water balloons as our squids. They fill them with water and food coloring to pretend it's ink.
Here we go.
It is farting out some ink. And it's spinning.
Look at them go! Just from the force of the water streaming out.
This is so cool.
If they want to escape, squids and octopuses suck water inside their body. Then they squeeze it back out a tube called a siphon. They can point their siphon in any direction. That's what makes the water jet propulsion that lets them rocket away like these balloons. Cool, huh? Thanks, guys.
Bye, Zoe.
There sure are a lot of squishy animals in the sea. But what about on land? You don't ever see a giant squid walking down the street. I wonder why. Well, it turns out there's a good reason. If they lived on land, they'd hardly be able to move. In the sea, all sizes of squishy animals do just fine because the water can support their body. Sort of like how you float when you swim. That reminds me of this question I got from Danielle.
How big do giant squids get?
Giant squids are the largest, awesomest squishy animals in the world. They grow as long as 13 meters. That's the size of an entire school bus. I think I feel a song coming on. I've got no bones. I'm the size of a bus. I'm a squid who lives in the ocean blue. Oh, here in the water I go as I please, but on land I flop around like a pile of goo. Pile of goo? If it's squishy and boneless and wanna be on land, a word of advice between me and you. To live out of the water, you'd better be small, so you can hold your body up and hide from you-know-who. Just stay small and slimy, that's all you have to do. Yep, on land, the bigger a boneless, squishy animal it is, the harder it is for it to move. So they don't get much bigger than this. Hi, snail. Hi, earthworm.
You're just the cutest little things ever, aren't you?
Look at how this worm moves around with no arms or legs. The trick is that he fixes the back of his body to the ground and then pushes out his front part. His muscles act like a spring. Look at it go! Now here's a question about my little sluggy friend from Kiara.
Why are slugs so slimy and like squishy?
I checked, and I found out that slime is really useful stuff. It helps slugs and snails glide across the ground and stick to a surface so they can climb straight up. It also keeps their body from drying out and protects it from getting cut on anything sharp. Hey, all that slime gives me an idea for...
My Great Challenge!
This is the slipperiest, sloppiest, slimiest challenge yet. Emma and Audrey, you'll be Team Ooze.
Yeah!
Chris and Justin, you'll be Team Goo.
Yeah!
You're going to help me test out the slug slime in the messiest way possible. The buckets in front of you have slime in it. You're going to cover yourselves with it and slide down the course. But first, I want to see if you can slide down the course without using slime. I need one volunteer from each team. Okay, Audrey and Justin. You can wriggle, push with your feet, and pull with your elbows. You're not allowed to use your hands. And remember, you're a slug, so your belly has to stay at all times in contact with the course. Go ahead. Let's test out your slug skills. It's pretty hard, right?
Yeah.
Aha, as I suspected. We're gonna need grade A slime to slide the course. Here's how the challenge goes. Justin and Audrey, you'll be the slugs, and Chris and Emma, you'll be the slimers. Slimers, you're gonna cover the front of the slugs to help them slide to the finish line. And slugs, if you ever need more slime, yell, need more slime! And slimers, you're gonna slime them, and then you'll switch. Are you ready?
Yeah!
Slimers, start sliming.
Okay, all slimed up. Now go!
Hurry up, Slug! Let's go, Audrey, go, Audrey, go, Audrey.
It looks like this is gonna be a tight yet slippery relay race. In a relay race, your partner continues the race and you get back. First team to finish wins.
Go, go, go! Chris, get out.
Remember, when you're done, you can start sliming your teammate.
I need to get slimed.
Go!
Team Goo has a late start, but they're not far behind.
Almost there.
What's this? Team Goo looks like they're not moving at all.
Need more slime. Need more slime.
Okay, go back.
Oh, whatever. Not enough slime, I suppose.
Team Ooze wins! Yeah! Why do you think slime comes in handy for slugs?
It helps them move easily and climb walls.
To protect their skin from rocks and scrapes.
Because it helps them move around.
I think it's useful because it's slippery so it can, actually move.
Exactamundo. Well, thanks for taking part in my disgustingly slimy challenge.
You're welcome.
Now, here's our next question about another slimy critter.
Why do leeches stick to you? Yuck.
Great question, Noah. I found out that hundreds of years ago, some people actually wanted these squishy animals to suck their blood. And here's why. Flat Earth Corner! Leeches. Get your leeches here. It can cure whatever's wrong with you. Got a headache? Stick a leech on it. It'll drain that pesky blood right out of your head. Sore knee? Stick a leech on it. Stomachache? You bet. Let these little suckers go to work. There's nothing they can't cure. Leeches are soft-bodied invertebrates that are specialized in sucking your blood? Hundreds of years ago, doctors actually used leeches to treat everything from ear infections to stomach aches. They believed that all you had to do to cure an illness was to drain blood out of the body. Wait a minute. What? It says here that some doctors still use leeches today. You mean leeches can actually heal you? This I've gotta see.
To help me find out the healing power of leeches, please welcome real-life surgeon, Dr. Demetrios Rizes.
Hey, Zoey. Brought you some new friends.
Ew, they're like small slimy vampires. Sorry, guys, but you give me the creeps.
Well, let me help you guys get acquainted and show you how these little guys help surgeons like us.
Okay, little bloodsuckers, I'll give you a chance. Ugh, they have the weirdest alien-looking mouths ever.
Well, that's because they have 3 sets of jaws and up to 60 teeth. They also have a sucker that when they bite, it latches on, but you never really feel them bite.
Why?
Well, they have this special saliva, and they have this compound in it that's kind of like an anesthetic, sort of like what you get at the dentist. You want to touch one?
Sure.
We're gonna need gloves for this. You ready?
Yeah.
There you go.
I did it! I'm actually holding a leech. Cool. So what do you use them for?
They have other special compounds in the saliva, including one called hirudin, and that helps fight clotting. Clotting happens when your blood vessels close up and you stop bleeding.
I don't get it.
Sometimes bad accidents happen. People could lose fingers, and reconstructive surgeons such as myself need to reattach them.
Gross. But so interesting.
If someone loses a finger, surgeons can sometimes sew it back on. Leech's special spit not only prevents clotting and infection, it also makes the bite painless. Best of all, these little bloodsuckers help make sure the person doesn't bleed too much during the surgery.
After a long surgery that could be up to 16 hours, you want to make sure things go well, and the leeches help us do that.
Wow, amazing. Okay, guys, you're not so bad after all. Leeches are squishy animals with no bones. Does that help them with what they do?
Being an invertebrate, they're able to suck up a lot more blood than their body volume. So they could drink up to 3 times their body size in blood.
Do they just keep drinking and drinking until they burst?
Well, no, they know when enough is enough, and they just drop off afterwards.
Thanks for showing me that these little bloodsuckers can actually be your friend. Speaking about healing powers, Maya has a really interesting question.
How do worms grow back their body?
Well, Maya, I checked. And if a worm gets cut in half, it can't grow into 2 worms. The front half may survive, but only if it has all the organs it needs, like its 5 hearts and its brain. But it wouldn't be a nice thing to do to the poor little worm.
I wouldn't do that. It's okay, don't worry.
But many soft-body invertebrates actually can regrow body parts, like an octopus. It can regrow its tentacles. One squishy animal is a master at regrowing itself. It's a sea cucumber, like the one I got to touch at the aquarium. If a piece of it gets broken off, it just goes off and grows into a whole new sea cucumber. Could you imagine if we could do that? I wonder what my friends would do. Ask a friend. Hey guys, what would you do if your arms and legs fell off and grew into new copies of you?
It would be amazing. I would never be scared of getting into an accident, and my body parts would always grow back.
Make them do all my chores.
I would fight crime.
If I had a body part that can regrow into me, I would love it. I can just chop off my arm and have a new one. It's like I'm getting reincarnated, and I can have like a foot where my hand should be and a hand where my foot should be, and I'm gonna look like a Godzilla.
I would make them my little minions, and they do whatever I want.
I think it would be fun at first, and then it would probably get annoying. Oh man, my clone ate the cereal again. Good thing we're not boneless like sea cucumbers. Hey, that brings us back to the question that started off the whole show.
I wonder what we would look like without bones.
The big answer is, we look like blobby sea creatures, and it would be hard to get on pants. If we were living on land with no skeleton or hard parts, we'd have to roll and flop our way to the ocean and grow some gills. That's because we're so big, the only place we'd be able to get around is in the ocean, with the water holding our bodies up. So, if we had no bones, and we had to live on land, we'd have to be a whole lot smaller and slimier. Like these little guys.
I guess it's worth keeping me around after all.
Yeah, you're pretty useful for us to run, jump, and play.
Yeah, unless you're a lazy bones.
Good one. That tickled my funny bone.
Another good one.
There's a crazy thunderstorm outside right now. And there goes the power. Which is totally okay because I'm not afraid of the dark, like, at all. I wish I could light up like these glowing stars. I could be my own nightlight, and then the darkness wouldn't get me. That is if I were afraid of the dark, which I'm definitely not. Hey, speaking of being my own nightlight, here's a great question I got from Aiden.
If fireflies glow in the dark, why can't we?
Yeah, why can't we glow like a firefly? I've never actually tried to glow. Maybe I just have to concentrate. Oh, nothing's glowing. Why can't we make our own light like fireflies? Or like comets? Or lightning? I don't even know how we make electric lights. But maybe your questions about things that light up will help me find an answer by the end of the show. A good place to start is to find out more about creatures that know how to glow. Here's another question about fireflies. This one's from Sean.
Why do fireflies' butts glow?
I checked, and I found out that fireflies' butts light up for one main reason: romance. I found out that fireflies have two special chemicals in their bodies, and when they mix together, they create light, kind of like a glow stick. They can control these chemicals to turn their light on and off whenever they want. Different kinds of fireflies can make yellow, green, orange, or even blue light. They actually talk to each other with patterns of flashes from their butts, like secret codes. Yoo-hoo! The male fireflies flash a message to say,
"Hey, I'm a certain type of firefly, and I'm going to tell you a little more about myself."
And if a female likes what she's seen, they'll flash back. Then the male follows her flashes and flies over to meet her.
How romantic.
What a great way to find each other in the dark. Actually, they're not just sending sappy messages. Their flashes can also warn hungry predators to stay away because they taste really bad. We might not be able to glow, but we can use lights to communicate like fireflies do. Ooh, I bet my friends know some ways that we use lights.
Ask a friend. A police car has a red light on top which says "Get out of the way."
Lighthouses shine light on the rocks, then the ships could see the rocks and then they would turn back. Like when we're driving and we see the lights says green, red, and yellow.
If you flash lights in specific ways, like turn it off and on, I think it can be Morse code.
Holy moly, you're right. We use flashing lights to communicate all the time. Hey, wouldn't it be funny if we did all that with our butts? You know, just like fireflies.
It's the police. Come out with your hands up.
If you could make any part of you light up like a firefly's butt, what would it be?
It would be my wrist, probably my nose.
Somewhere on my face, like my eyes, my nose, or my mouth.
My nails for like Halloween parties and stuff. I think I would want my head to glow so people can see my face.
Ooh, yeah. You could be a ghostly floating head in the dark. Ooh. This next question is from William. Ooh. Do some fish glow in the dark?
Do some fish glow in the dark? Well, I checked. And on land, there aren't too many animals that can make their own light. But underwater, it's a different story.
To find out more, I swam to the darkest depths of the ocean. Not really. I'm actually in the very dark laboratory of Dr. David Morse, a biologist who specializes in glowing sea creatures. Whoa, what is that?
This is a flask of dinoflagellates.
Huh, it glows. Oh, hello.
Hi, Zoe.
That looks like plain old water in there. How come it was glowing?
Well, it's not plain old water. It's actually full of creatures, and they're really amazing because they produce their own light.
I don't see any creatures.
Well, they are so small, you actually need a microscope to see them.
Wow. Incredible. But why do you have to stir them up to make them glow?
They're sensitive to movement, like somebody swimming in the ocean or a predator swimming after them and trying to eat them. And their response to that movement is to give off a flash of light. Either to scare away those predators or to attract predators of the predators.
They use the light to communicate to the predators of their predators?
That's right, but any movement of the water will make them give off light. There are places where the beaches glow at night with the waves, and the water lights up. It's really beautiful.
Amazing. Can I see one close up?
Sure.
Wow. All those creatures were in that water?
Yes, and they even have tails to help them swim.
They're so cute. How do they make that light?
The same way that fireflies do. They burn a molecule called luciferin, and that produces the light.
Cool. Are there any kind of fish that use light to communicate?
Lots of them. In fact, most of the fish that live in the bottom of the sea are bioluminescent.
Dr. Morris tells me that bioluminescence is the chemical reaction that makes some creatures produce their own light.
It's very vast and dark in the deep sea, so the creatures there use light to find and signal their mates or to lure in their prey.
Cool.
Did you know that some animals can actually scare off their predators with bursts of light? And others can hide by lighting up their bellies to perfectly match the light coming down from above, so their predators can't see their silhouettes.
Which way did he go? Holy cow. There are so many fish and other sea creatures that can glow in amazing ways. Hey, can I keep some dinoflagellates as pets?
Sure you can. I put some in this tube for you. All you have to do is put them in the sunlight every day, and then they'll light up at night.
Cool. I'm so excited. I'm going to name them all.
I should tell you there's probably about 1 million in there.
1 million? Now I have to think of 1 million names. Okay, I'll name you Sparky, you Twinkle Toes, you Lightning, you Thunder.
This could take a while.
You Twilight. Boy, I'm going to have to think of a lot of names. Meanwhile, here's another question about glowing animals from Deborah. How come a neon fish will glow at night when you shine a bright light at them? Well, Deborah, I checked. And some animals don't make their own light, but they're really good at reflecting it. Neon fish have crystals in the skin underneath their scales that reflect light. Kind of like the reflector on your bike. But without light, you can't see them. And check this out. Some fish reflect light in an extra cool way, by changing color. It's called biofluorescence. These fish live in the deep, dark ocean, where only blue light gets through. When that blue light hits them, it's reflected as green or red light. That's because biofluorescent fish have special colored lenses in their eyes, kind of like sunglasses. They stand out like a light bulb in the dark, and that's how they recognize their own kind. That gives me an idea for...
My Great Challenge!
I have here with me Jeremy. I'm going to call you a squigglefish.
Yeah!
And Molly, I'm going to call you a splatfish. Yes! You each have different hidden patterns on your arms that you can only see with these black lights. That's kind of like using the special eyes that some fish have for finding the hidden reflecting colors of their mates. You get to do almost the same thing in this challenge. Use your black light to find the biofluorescent fish with your pattern on it. Oh yeah, and some fish have no pattern at all. Just to trick you. Your challenge is to find as many fish of your own kind as you can in 2 minutes and take them back to your home base right here. Are you ready?
Yeah!
Then go find your fishy matches. The one who gets the most fish wins. Squigglefish found a pattern right away, but it's Splatfish's pattern.
I keep on finding them that don't match.
Splatfish looking for a pattern. Yes, it checks out. That's one for Splatfish, but Squigglefish has one too. And Squiggle gets another right away. That puts him in the lead, 2-1. Squiggle looking for another match and finding it. Get moving, Splatfish. So far, Squigglefish has 3, and Splatfish catching up now with 2. Splatfish gets another one, but so does Squigglefish. The deeper you go in the ocean, the bluer and darker it is. That's why biofluorescence is amazing. Animals that can make these colors and patterns light up brightly can use them to see each other in the dark, avoid predators that can't see them, and find a mate to have babies with. Only 10 seconds left!
Can't find any more.
Can Splatfish catch up? Oh no, this fish has no pattern. It's not bioluminescent. Splatfish is wasting her time. Okay guys, time's up. So Molly, you have 5 points. Yay. And Jeremy, you have 6 points.
Yes!
So you win. And now, time for a blackout party. This is almost as much fun as this question from Andeline.
Why does a comet have a glowing tail?
Flat Earth Corner! No. This is a
a terrible sign. That devil star will bring us nothing but earthquakes and plagues of sickness. The rain will turn red with blood, and animals will be born with 2 heads. Run for your lives! And while you run for your life, do it in style with these Devil Comet t-shirts and buttons. Or commemorate the end of the world with a pendant. I've got every souvenir for the comet apocalypse at low, low prices.
Pretty much every ancient culture in the world dreaded seeing a comet in the night sky.
I found out that they thought the comets were sent by gods to bring war, illness, and destruction, and every bad thing you could imagine.
Luckily, thanks to science, we know a lot more about them now. In fact, I've got some experts who are going to help answer your question, Andelaine.
Please welcome astrophysicists from the McGill Space Institute, Robert and Gabrielle.
Hi, Zoe.
Hi, Zoe.
Hi. Wow, what is this?
This is dry ice.
We're going to use it in a minute to make comets.
Cool.
It's actually extremely cold.
Wow.
Okay, so here are all the ingredients we need to make our very own comet.
Like a comet cake mix.
But I certainly wouldn't want to eat these cakes.
Most comets have dirt and they have dust in them. So we're gonna use the sand here and the dirt and we're gonna mix it in the bag. And you can do the same with the dirt now.
So we mostly think of comets as dirty snowballs in space. So we already have the dirty part, but for the snowball bit, we're gonna use some water. So now we have pretty much a mud pie. Now we need to make it into a comet. We're going to use the dry ice we found earlier to freeze our comet. Then we don't want to freeze our hands. We have some mittens to put on. So I'm just going to add a few scoops of this. There we go, and one more for good measure. Okay, so you want to push that all to one side of the bag?
I can help. We can take the comet out of the bag and look at it.
Wow, it looks like an ugly snowball.
And that's exactly what comets look like when they're really far away from the sun.
So, how does it light up?
If you were to blow on the comet...
Wow.
You see, it's producing a tail.
That's just like what happens when a comet gets close to the sun. It starts to melt, and it leaves behind a big, long vapor trail. The sun pushes the vapor trail away from the comet and gives us the big tail we see in the sky.
Oh, so the comet's tail always points away from the sun. But what makes it light up?
It just reflects the light of the sun.
Oh, I get it. It's the same way the moon shines.
Exactly.
Well, thanks for being on my show.
Thanks for having us.
I have another question from Andrea about lights we see in the sky.
Why is lightning so bright?
I checked, and I found out that the big flash of light is created by electricity that builds up in the clouds. It's kind of like what happens when your socks stick together when they're tumbled up in the dryer, and you try to pull them apart. They zap. Check out this cartoon I made. Tiny pieces of ice form high up in the sky, where it's really cold. These ice crystals turn around in the wind, and they bump against water droplets and other ice crystals. As they rub and bump into each other, they build up an electrical charge. Eventually, the charge builds and builds to form a gigantic spark. The lightning's bright flash comes from that spark. Did you know that a bolt of lightning can give off as much light as almost 17 million light bulbs at once? That's a lot of light bulbs! Uh-oh, do try this at home! Emerald and Linnea are going to show you how to make your own mini lightning with just a balloon and a spoon. Here's what you do. Rub the balloon on your hair till it gets good and staticky. You'll know it's ready when your hair stands up and sticks to the balloon.
I think it's ready.
Then in the dark, bring a spoon close to the balloon.
Oh, there's a little spark.
Wow, did you see that? It's tiny lightning.
Bye, Zoe.
Nature has some cool ways to make light. What about us humans? Here's a question from Andrew.
How did people see in the dark when there was no light?
Tired of dark when day goes away? Try new fire stick. It light up your life. Invention need work.
The first thing humans used for light was fire. But it's dangerous and burns out really quickly. But I found out that eventually we learned how to make it burn slower. We burned moss soaked in animal fat, which led to the first oil lamp. After that, we made candles out of wax. But when we figured out how to capture and control nature's electricity, everything changed. This is a perfect time for Sophia's question.
How do you make a light bulb?
How do I make a light bulb? Ding! I asked my scientist friend, Shakib, along with Daniele and Andrea. He knows how Thomas Edison made the first really useful light bulb back in 1879.
It's important to do this with an adult because it can get a little bit dangerous. Andrea here is going to help me. So what I need you to do is take this toilet paper roll, tape my 2 alligator clips to the side of that. And Daniele, I'm going to have you use our thin piece of filament here, which is actually a piece of picture wire, and attach it onto our alligator clips. And now I want you to cover it with this jam jar that I cleaned out earlier. The last thing we'll need is some electricity to send through the filament so that it glows. I have a battery pack here. I'm going to connect. What do you guys see?
Fire, light and burning.
Yes, we made a light bulb.
Cool.
Yeah, that's for sure.
Uh-oh.
Wow, did you guys see that?
Yes, it just burned.
The filament's completely gone, but we do have a way to make the filament last longer. What's in the jar, you guys?
Air.
Very good. So if we remove the air from the jar, we can actually make our filament last a little bit longer and have a better light bulb. So we've got a candle here, put that in here, and we have to attach a new filament. And what we're going to do with our candle is light it. So a candle requires a couple things to burn. Of course, it needs the fuel, which is the wax that we have in the candle, but it also needs air or oxygen to burn. If we use the jar and we cover our candle, what will end up happening is we won't have any oxygen left. Can you see that the candle flame starts to get a little dimmer?
Yeah.
And then it goes out and we get a nice puff of smoke. So then we know there's no oxygen left inside our jar. And I'll just connect the other clip here. And look, this time it lights up, but it doesn't burn because there's no oxygen inside. Edison tried a whole bunch of different filaments for his light bulbs, but it wasn't until he removed the air and created a vacuum inside that he invented the electric light bulb.
And the rest is history. That was an awesome experiment. Thanks, guys.
Bye.
Well, when it comes to lighting up from fire to fish that glow, nature's had it figured out from eons long ago. But when we use our brainy minds to follow nature's lead, we use the things around us to create the light we need. Oh, we made oil lamps and torches, fireworks and candles, lanterns, light bulbs, luminescent lights on our bike handles, neon signs, glow sticks, laser shows and movies, traffic lights, this lightning thing. These flashy shoes are groovy. There's headlamps, pyrotechnics, lit up fair rides, computer screens, holiday lights, lighthouses.
You're gonna make my head explode!
Phew! We've harnessed light to do so many amazing and silly things. But I still can't get my own butt to glow like fireflies. No fair! And that brings us back to the question that started off the show.
If fireflies glow in the dark, why can't we?
The big answer is we actually do. Well, not enough to see with our eyes. Only just a tiny, tiny amount.
I found out that all living creatures give off a very small amount of light because of the activities of our cells. We humans have never been able to make our own light on purpose, though, the way cave worms and deep-sea fish do. That's because we don't live in constant darkness.
But we were smart enough to figure out how to make the light we need with stuff we found in nature. Which means, hello and welcome to Finding Stuff Out. You'll have to watch and listen closely today. Your eyes may fool you. Your ears may trick you. Your mind itself may deceive you. Because today's episode was all about fooling the brain.
I got the idea of a mind-boggling, mysterious episode from a question I received from Alessia. Wait, where's my remote? Oh. Got it.
How do illusions occur?
Well, Alessia, I don't know, but by the end of the show, I'll find out why illusions occur and why they fool our senses. Ow, my toes itchy.
Mom, can you come here a minute? I don't think she heard me. I hate it when this happens.
Yeah, that's better.
An illusion is something that can fool your senses. It can be visual like a magic trick. Fooled ya! It can also trick your other senses, like your sense of touch and hearing. In a few minutes, we're going to meet a professional magician who's going to show us a few illusions. But first, Victor asked me about animal illusions.
How do animals use camouflage?
I found out that lots of animals create illusions using camouflage. It's a way of hiding by blending in with your surroundings. Animals do it to avoid being eaten or to sneak up on their prey.
Animal magicians, they can fool your eye, changing shape or color like those sneaky octopi. Some use camouflage so that they look like other things. Some have scary eyeballs that aren't real on their wings. Some camouflage to hide from creatures they don't want to meet. But some use it to sneak up on the ones they like to eat. So when you see magicians pulling rabbits from their hats, remember bunnies have their tricks and two can play at that.
Some animals use illusions to trick other animals, besides camouflage. You might wonder why zebras are black and white, since where they live is green, brown, and beige. Well, I found out that lions, which love to eat them, are colorblind.
That means lions can only see black, white, and gray.
They can see the zebras, but the stripes confuse them. When zebras all run together in a herd, the lions see this. They can't figure out the zebra's size, shape, speed, and direction. That makes it really hard for the lion to catch one single zebra. And about 100 years ago, people copied this idea on ships called dazzle ships. Their stripy paint job confused submarine captains trying to aim torpedoes at them. Because, just like zebras, the dazzle ship's stripes made it hard to tell its speed and direction.
Now here's a question about another kind of illusion.
Is it true that thirsty people in the desert see water that isn't there?
I found out it's true. In the desert, sometimes you see water when there's none. It's called a mirage.
Water! Huh?
A mirage is an optical illusion. In the desert, when it's hot, the air near the ground gets heated up.
When light travels from the cold air above into the warm air, it gets bent. We're used to seeing air traveling in a straight line. So when we see the light get bent, it looks like a pool of water. Of course,
sometimes things that look like they are there really are there. But if your brain has been tricked before, it might just think you're being tricked again.
Even when you're not, sometimes there really is water in the desert. It's called an oasis.
Now here's a question from Jenna. Why do optical illusions trick your brain? To answer your question, I've come here to the workshop of professional magician and master of illusions, Professor Wick. Come on. Professor Wick.
Hi, Zoe. How are you?
Good. How are you?
Well, actually, you know what? I'm feeling a little bit lightheaded.
I'm not surprised. You look a little lightheaded. In fact,
I don't know how to break it to him. Professor Wick, you don't have a body.
Well, you know what? It's all an illusion. A grand illusion created by a reflection.
How do illusions trick your brain?
Tell you what, I'm gonna just get my head back in order here, and I'll show you how illusions trick the brain.
So it looks like the lights go on forever, but I'm pretty sure your workshop doesn't go on forever behind this wall. Or does it?
Nope, it doesn't. If you look very carefully on the side, you'll see how thin it actually is.
Wow.
You see? And yet it looks like it goes on and on. But now watch what happens. I'm going to take it off.
Whoa.
And there it is.
Oh, yeah.
You see? One set of lights, a mirror, right there. And this is actually a mirror as well. And as soon as you put it on there, look what happens. When two mirrors are facing each other, the image is repeated over and over and over again. Okay, check this out. Who's that photograph of?
Yeah, it's me.
It's you. Now check out what happens when I turn it right side up.
Oh my goodness, that's so weird. What happened?
Pretty weird, right? We took a picture of you, and then we took your eyes and your mouth and turned them upside down. When the entire picture is turned upside down like that, your brain doesn't register the fact that your eyes and mouth are upside down. It looks perfectly normal. Here we have a whole bunch of words. They're all different colors.
Yeah.
What I want you to do is, as quickly as you can, from here all the way across, I want you to say the color of the word. Don't read the word.
Sure.
Go ahead.
Green, red, black, blue, pink, red, black, red, yellow, yellow, green, blue, blue, orange, red, green, pink, yellow.
Way better than I could ever do it.
I mean, it was hard because you already know the word, and it's like, oh, I gotta put the other word first.
Or the color.
Yeah, the color.
Yeah. Your brain can process a word much faster than it can process a color. So while you're struggling to say the color, your brain has already got the word, and it wants to say it. So now, Zoe, I have one more special illusion for you.
Professor Wick?
I'll show you later.
Oh, well, that gives me an idea for...
My Great Challenge!
Hi, guys. Welcome to my show, Caden and David. Are you ready to fool people?
Yeah.
Caden and David are learning to be magicians, and they practice a few tricks for this challenge. To judge you guys, I've invited Swapna.
Hi, Zoe. Hey, guys.
Hi.
Nice to meet you. You know what? I forgot my notes. Let me go grab them.
Okay.
Mac,
Whoa. Whoa, where were you? Is this an illusion?
Is there a...
Oh, yeah,
No.
there's a... Oh.
This is my twin sister, Sandhya.
Hi, Zoe. Hi, guys.
Hi.
We study the same thing. We study brain injuries and how the brain works.
And we do a little bit of magic on the side.
Cool. I guess there's gonna be two judges then. Please welcome Magician David.
Oh, yeah! You see 3 dice. Now I'm gonna put one in my hand, the second one in my hand, the third one in my pocket. How many do I have left?
2?
You're wrong. Let's do it again. One in my hand, second one in my hand, the third one in my pocket. How many do I have left?
3?
Okay, now I'm gonna put one in my hand. Only one, okay? And the 2 other ones in my pocket. How many do I have left?
1.
You're right.
Wait, why is it red?
Magic.
Please welcome Magician Caden.
So I have a shoelace that I tied together, and I have my finger ring. So I'm just gonna take that up, and I'm just gonna hold it in a loop.
What? How did you do that?
I can't tell you, but I can show you another trick.
Sure.
I have a normal pack of cards. So just try shuffling the deck. Ready? Okay. We're gonna take the deck and put it there. Okay, just cut wherever you want. You got it? Now take the card, right there, and look at it. Don't show me what it is. So just put your card down on the pack, like this. Don't show me what it is. Okay, there you go. Now I'm gonna go through the whole deck. Put your hand out like this. Now I can sense the warmth from your hand and find out that your card is the 4 of clubs.
Okay, judges, what did you think about the performers?
Both magicians did an incredible job. It was really hard to choose. David, we really liked how you changed the color of the dice. It was really cool. And Kaden, both your tricks with the lace trick and the card trick were so well done. We really didn't know how you did it. But in the end, by a very slight margin, we think Kaden has won.
Congratulations, Kaden.
Thank you.
What was the most challenging thing about performing your illusion?
The challenging trick I found was the ring and the lace. It's a trick that nobody else has performed, and I was really kind of scared that it would go wrong.
David, what about you?
It was when I had to change the color of the dice. I was scared that you would see how I did it.
Well, thanks for being on my show and helping me find stuff out about how illusions trick your eyes. But not every illusion's about tricking your eyes, as you'll see in this question from Stefano.
What is a placebo?
The Flat Earth Corner! Gather round, folks. Do you suffer from frostbite, sore throat, toothache, bruises, and swelling? Then step right up and buy a bottle of Clark Stanley Snake Oil Liniment, made only with venom of the biggest, meanest, rattliest rattlesnakes. My liniment will cure anything. Who wants to be the first to buy it? You, sir? What about you, ma'am? Clark Stanley Snake Oil. More than 100 years ago, Clark Stanley sold thousands of bottles of his so-called snake oil. I found out that eventually snake oil was tested, and guess what? There was no medicine in it at all, and not even snake venom. It was all a trick, but people bought it and thought it cured them. That's an illusion known as a placebo effect. It's when you think you feel better, even though you didn't really take real medicine. New medicines need to be tested to see if they work. Half the people in the tests are given a new medicine. The other half are given the placebo, which doesn't have any drugs at all. Surprisingly, a lot of the time, the people taking the placebo think it makes them feel better. Placebos aren't the only type of illusions that trick your senses other than your eyes. Sanjay and Swap now have a few tricks up their sleeves.
So the first one we're going to do is called the McGurk effect. So this illusion shows us that we can't always trust our ears. So okay, can you tell me what you hear when my sister says this? Bar, 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 bar. What did you hear?
Bar.
Now this time just watch me while my sister talks. Bar, 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 bar. What'd you hear this time?
I heard far.
Ah, that's not quite right. You heard bar.
Are you sure?
Yeah, you saw her mouth form the word far, and that tricked your brain into thinking that you were hearing that word too. Bar, bar, bar. What you see can change what you hear.
Cool.
So our next illusion relies on two of your senses, taste and your sense of smell. Okay, so we're gonna need you to close your eyes, pinch your nose shut so you're only breathing through your mouth. I'm gonna give you a jelly bean. Tell us what you think the flavor is.
Is it lemon?
Not exactly. Okay, now I want you to just let go of your nose and keep chewing. What do you think it is now?
Is it orange?
Yeah, you're right. So what happened was when your nose was blocked, you were only relying on your taste receptors, which alone aren't necessarily enough.
I guess you tricked me again.
Now this is something called the rubber hand illusion. So what we have here is a rubber hand right in front of you, Zoe. And we've put your actual hand on this side of the screen so you can't see it. So we want you to focus on the rubber hand, okay? Okay, so now what we're gonna do is try and connect what you feel with your actual hand, which you can't see, with the rubber hand, which you can see, so you start to feel like it's your own. So how are you feeling?
Okay. Ow!
How do you feel now?
Weird. It's like I felt it.
So with the rubber hand, we were able to affect your sense of where your body and body parts are. So normally with your hand, you're able to sense where it is using your sense of sight and your sense of touch. But with the rubber hand, we messed with how you're able to combine those senses and how'd you connect with the rubber hand.
Your sense of sight is a powerful sense.
So for this next illusion, I'm going to be a guinea pig, and everybody else at home can join in and be guinea pigs too.
Stand right up against this wall here. Take the back of your hand, push against the wall as though you're trying to push it away. And keep doing that for about 30 seconds.
Okay, time's up. You can step away from the wall and you'll find that your arm starts to rise.
Look, your arm's floating.
What? How is that happening?
So what's happening is after a long period of voluntary pushing, we see involuntary movement. Hypnotists have used this to try and make their subjects believe they're being controlled.
I asked my friends if any of their senses tricked them, and here's what they said.
Ask a friend.
I was sleeping, and when I woke up, I saw something popping out of the window. And I think it was a zombie or something creepy, so I went to my mom's and dad's room to get a hug, and I came back and it wasn't there. So my brain really tricked me.
I saw a flying cat with a taco on his head.
What?
It's true.
I was going into my room, and I thought I saw my sister laying on my bed, and then I blinked, and then she wasn't there anymore. I thought like it was magic.
So far, we've seen, heard, and felt a lot of illusions. But some are part of our everyday life, and we don't even know it. Like right now, looking at me. What a concept.
I'm just an illusion?
Head getting warm.
How can I be an illusion?
Hang on!
You're gonna make my head explode!
You think you're looking at me in one continuous action, right? But guess what? This is a movie film.
Film and video are actually just a bunch of still pictures. By showing them one after the other really fast, you create the illusion of motion.
Want to try it yourself? Then it's time for...
Uh-oh, do try this at home.
Emma and Marco are creating their own movies by making flip books.
I'm drawing the man that walked a tightrope between the two towers of the World Trade Center back in 1974.
Oh, that's cool.
What are you drawing?
I'm drawing someone that's blowing up a balloon and then it explodes in their face.
That's funny.
The way it works is you do a simple drawing on one page and do a slightly different drawing on the next page, and do a whole bunch of pages like that. Flip books work because of the same optical illusion as film or TV. It's like making a very simple movie or video. Try it out.
Want to know how I know how to move my man?
How?
I press on the picture and look where his last foot was, and then I move his first foot to where his last foot was, and then it looks like he's moving.
That's a good trick. All I do is really look through the paper to see where it lastly exploded or how it blew up. And then I just make it a bit
smaller.
Yeah.
Those sound like good ways to do it. Let's see how they turn out. Wow! The little man really looks like he's walking along the tightrope.
You want to see mine?
Yeah. That's funny.
Bye, Zoe.
Bye!
I made one too. And now it's time to answer the question that started off our mysterious quest.
How do illusions occur? Well, Alessia, the big answer is... our brain. Our brains can be fooled by the way they're used to seeing the world.
Like when your brain expects light to travel in a straight line, and when it doesn't...
Water!
It makes you think you see water in the desert. When other things don't look the way your brain expects them to, you can see a head with no body.
Hello, Zoe. How are you?
Or think an animal is a leaf on a branch. Or think that you're hearing...
bar, bar, bar.
I heard far.
You heard bar.
Or tasting something different than what's really there.
Is it lemon? Or that you're watching someone moving on television, when really, you're just watching a series of still images that your brain thinks are moving images.
It can even make us think that we are seeing someone floating in the air. See you next time for more Finding Stuff Out.